So last time you guys were starting to look at vectors and working with vectors in terms of components. We're going to practice a little bit with that, with just the whole component idea and do some practice that work with it because that's the best way to learn it. So let's just start with something like this. Suppose we got a vector. We'll make something up here. Let's say we got 40 at, let's go with 35 degrees, and I want to know the components of that vector. Well, first things first, I'm going to draw the vector. I'm going to start with a little reference, little origin right there, and I'll use this. And 35 degrees would probably be something like that. So that would be 40 long, and my angle right there would be around 35 degrees. So I want to know what are the components of that vector. Okay, so remember, we take vectors that are angles like this and we make them to right triangles. So I'm going to start by doing that. So I'm just going to, and I always like to start where my vector starts. I'll draw my little x-axis, and then I'll go up to meet the vector, and there's my right triangle. And then once I have my little right triangle, I can use my basic trig in order to figure out my x and y components. So I'd want my x component, I'd want my y component. So my x component would be 40 cos 35, and my y component would be 40 sine 35, and I get my components. So if I do the 40 cos 35, I get a component of around 32.8. So this would be 32.8. So I'm just solving the triangle. And if I do the similar type of thing for my y component, I will get around 22.9. So that little side right there is 22.9. And it's going to the right, so my x component is positive, and it's going up, so my y component is positive. So that's it. So my x component is around 33-ish, and my y component would be around 23. Okay, so let's just do another one here. Let's suppose we got, let's go, let's change the color back to black here. Well, that's just terrible. There we go. All right, so let's try 85 at, let's go with 250 degrees. Okay, so I'm going to draw my little reference again. It comes in handy sometimes, especially when you're starting out. And I'll draw my line. So to the right would be 0 degrees. So I'll start curling up. That would be 90. That would be 180. Going straight down would be 270. I don't want 270, I want 250. So I'll crack it back a little bit. Crack around 20 degrees this way. So something like that. Okay, so my angle is 270 around this way. I mean, it's also negative 110. You could look at it that way as well. It doesn't make any difference. But there's my angle right there. So I got the 250. So again, I'm going to make a right triangle out of this. I'm going to start where I started from, make my little x-axis, and then drop it down to meet up, something like that. And just when I do this, if you remember I told you before, I like to use my smallest angles possible with the x-axis. I don't really like using the whole 250. If that's 250 wrapped all the way around, this would just be 70 degrees in there. And I'd much rather use the 70. I don't recommend using the 20 in there. I would use the 70 degrees, and that's the angle I like to use. So my x component and y component, let's see, so it'll be 85 cos 70 degrees and 85 sine of 70 degrees would be my two components. So I'll do my 85 cos of 70, and I get 29.1. And it is going to the left, so I'll make that negative. And y component, I've got the 85 sine 70, and do that, and I get 79.9, and it's going down, so that one would also be negative. So those would be the x and y components of those two vectors put together. Or not those two vectors, but those are the x and y components of that vector. Now, what if we wanted to take these two vectors and combine them together? Okay, so let's add the vectors. All right, so if we wanted to take these vectors and add them, let's put them together. If you remember from before, you take each one, make it a right triangle, find the x component, find the y component. And then what we do is we put the total components together. And it's really common to use a little XY chart to help organize. So for the first one, my x component was 32.8. My y component was 22.9. For the second one, x component was negative 29.1 and negative 79.9. And then I am going to total those together. So I got 32.8, and I've got the minus 29.1, and that leaves me with an x component of 3.7, which tells me right now that this thing isn't going very far sideways anymore. Okay, where am I getting my answer? All right, but I got the 22.9, and I'll put that together with the minus 79.9. I'm going to put them together, and I've got negative 57. So just looking at that, negative 57.0, just looking at this, I can tell that this thing, isn't going very far sideways, and it's going really far down. So my answer is going to be going pretty much straight down. Okay, so well, let's piece these together. So I got my total x, I got my total y. So now I will make my new triangle, and I always like to start with my x first. So starting nub, so 3.7 sideways, and then I'm going to go down 57. So there's a whole bunch going down. And then that tells me that my answer would go from beginning to end. My answer would be something like that. And of course, it's right triangle. So the hypotenuse is going to be pretty much 57. In fact, you should get around 57.1. It's almost the same length as the one side. So what about the angle? So we're going to get the angle here, and I would solve for this angle right here. I always like to go from my x-axis to the resultant. So I like to use tan theta. I'd probably use tan theta of the 57 and the 3.7. So if I do that, I can find my answer or my angle inside of here. It's going to be a big angle. It's almost 9 degrees. And if I actually calculate it, I actually get right inside there. It's like 86 degrees. So that's the angle I like to use. Now it's going, here's my positive x-axis, and all angles are typically measured from there. And it's 86 down. Like, you could wrap it around all the way around to be like 274, or you could just say the 57 at negative 86 degrees. Now I would just like to use the 86. You could wrap it all the way around and say 274 if you wanted to. Doesn't matter. But I'd use the negative 86. Okay, so this is basically what we were working on a little bit last time. Take the vectors, how far sideways, how far up and down, add their components, get the totals, and then make your new triangle and solve the triangle with that. Okay, so let's continue practicing with this a little bit. We're going to go back to a sheet that should look familiar and do some more work with this. All right, so hopefully this looks familiar. We did this sheet before, except we did it with just drawing scale diagrams. But now we're going to actually try and do it more accurately by using actual trig and Pythagoras to solve for things. Now, the nice thing is you guys already have the answers for these. They aren't the exact answers, but they're approximate answers and have an idea what the things should look like. And that's what we're going to use this to make things a little bit easier for ourselves. Okay, so if I was just going to do a plus d, and we got the same measurements as last time, no big deal. If we do the same questions, the first thing I'm going to do is I'm going to sketch this out. It's always a good idea just to sketch this out. So if I sketch A goes across something like this, and then plus D was up something like this, and then from beginning to end, my answer was something like this. I don't need a ruler, I don't need a protractor. All I need is a rough sketch of what's going on in order to see my positives and negatives, and I can estimate my answer. Okay, so now what I'm going to do is I am going to make my little XY chart. So, oops, let's get a gray back. I'm going to do a little XY chart and take each vector in turn, how far sideways, how far up and down. So if I go to my first vector, that's vector A. Vector A is just going straight to the side. So that's really easy. So the X component for vector A would be 2.5 because that's how long it is. Y component is 0 because it's not going up and down at all. Okay, that vector's done. Don't worry about it. Move to the second vector, which was the D vector. Now the D vector is going up and to the left. So the D vector, of course, is going up like this. So I am going to make a little right axis and I'm going to write x-axis, little y-axis, and make it into a little right triangle, something like this, and break apart it into components just like we've done before. I know it's 1.7 long, and the angle on the outside is 125. I probably wouldn't use the 125. I think I'd rather use the 55 degrees that's in there. Some people like the 125. It doesn't really matter. I like to use smaller angles when I calculate this stuff. All right, so what I'm going to do is I'm going to do 1.7 cos 55, and then I'm going to do 1.7 sine 55 and get my x and y components. So if I do 1.7 cos 55, I can find out this little side part here is, and we'll round off a little bit. It's about 1.0. And if I do the 1.7 sine 55, the little vertical part here is around 1.4. And those are the parts I'm going to use in my little table of values. So my x value is 1.0, but that one's going to the left. So I'm going to make it negative. Okay, y component's 1.4. It's going up, so that's fine the way it is. So I've got my x component for the first one, my y component for the first one, my x and y components for the second one. All the pieces are done. Now I'm going to take these guys and I am going to put them together. So I got 2.5 combined with a negative 1, so that's just 1.5. And of course those put together is 1.4. All right, so I've got my total x, I've got my total y. And you can see when I'm doing this, I didn't write out my trig functions, that kind of stuff. Once you get the hang of it and you know how to solve the triangles, you don't need to show all that sine and cos stuff if you know what you're doing. Like, it just becomes more efficient, a little bit quicker. Okay. All right, so now that I've got my totals, just like before, I'm going to draw my new triangle. I'll make a little nub. Okay, I've got 1.5 in the x direction, then I'll go up 1.4 in the y direction, and then I've got my answer going across something like this. So now I'll use my Pythagoras and my trig to solve for it. So let's use Pythagoras to solve for the hypotenuse. So I've got the 1.5, I'll square it, plus the 1.4. I'll square it, and then I will get the hypotenuse, and we'll round off. It's about 2.1. Okay, there's my starting point. I want my angle from the x-axis to my resultant, which is right there. So it's just under 45 degrees because those two sides are the same. So if I'd probably use tan theta for that. We get around, it's 43 degrees in there. All right. So my hypotenuse is 2.1, so the answer would be 2.1, and it'd be at 43 degrees. And that angle is measured from the positive x-axis from where I'm starting from, so that's perfectly fine the way it is. And if we go back to when you guys did this drawing, right now we got 2.1 at 43, and when you drew it, let's see, the estimate was like 2 at 40. So 2 at 40 is actually really close to 2.1 at 43. Okay, so it works out a little better, and everybody would get the same answer doing it this way. All right, so let's try the second one, which is the c minus b, and do the same type of thing. So first thing I'm going to do is I'm going to sketch it out. C minus b, so I would have c would something like this, and then b plus b would go down, minus b is going to go up, something like that. All right, so now what I have to do is I got to break apart my vectors and piece things together. Okay, so I'll do a little XY chart again. All right, so my first vector is this one right here, my C vector. I'm going to have to turn that to a right triangle, break it apart. Okay, so that's 3.6 long at 18 degrees. So I'm going to do 3.6 cos of 18, and I'm going to do 3.6 sine 18. It's going to the right, it's going up, so everything's going to be positive, so it's a little bit easier. So the sideways part here, if I just solve for that part right there, is around 3.4, and this is 1.1. So I'll put that into my chart. 3.4 sideways, 1.1 going up. Now, of course, the second vector is super easy. That's just b going straight up, and that was like 1.0 long. So the x component for this guy right here is 0, because it's not going sideways, and the y component would be 1.0. All right, I've broken them apart. Now add up all the x's, add up all the y's, and I've got my two totals, 3.4 and 2.1. Now that I have my new totals, I can make my new triangle. So if I make my new triangle, it's 3.4. I'll make a little starting nub. So 3.4 sideways, positive, and 2.1 up, also positive. And then my resultant is going from beginning to end, something like this. So once again, I can solve for my hypotenuse using Pythagoras. Is going to work really, really well. So if I solve for that, it's probably around 4 or so. And yeah, it's 4.0. So this is 4.0. We can solve for the angle. And I probably use inverse tan for that right there. And if I solve for this angle, it's like 32 degrees. And that angle is from the positive x-axis. So that's perfect. So answer for this one, those two vectors put together gives me 4.0 at 32 degrees. And if we check the estimate we had last time from the sketching, it was 4 at 30. So there we had 4 at 30. Here we've got 4 at 32. So that's awesome. And of course, if we, had done the sketching, we just drawn like this, and that looks pretty much the same, which is exactly what we want. Okay. All right. So let's try the next two. Now, keep in mind when you're doing this stuff, especially when you're first starting out, if you miss a positive negative, it's no big deal. If you got your x and y and the values flipped, no big deal. Pick the wrong angle, no big deal. A lot of this comes with experience and just figuring stuff out. And quite frankly, the little mistakes never go away. You're like, it's just the way it is. So don't worry about it. Just keep on going. And the mistakes never go away, but you get less and less and less of them as you do more and more of it. All right. So let's just keep on going with this type of stuff and calculate the bottom two. And again, we've already got estimates for them. We have an idea what they look like from the previous time we did this sheet, but hopefully we can get some more accurate, consistent results here. And again, if your answers aren't exactly the same as mine, it's probably like decimals and calculator type thing. Don't worry about it. As long as you're close, you'll be good to go. All right, so let's look at a plus 2b minus c. So a plus 2b minus c. I'm actually gonna take this stuff right here, and I'm actually going to move it. I'm going to copy it, and oh, come on. Oh, get rid of that. Copy that. Oh, that didn't work. Now let's try this again. So I'm going to take this. I'm going to move it down here so I can actually see it a little better. There we go. Okay. All right. So you got a plus 2b minus c. All right. So a was straight to the right. Something like this. 2b was on the way down, but there's two of them. So something like this. C was going up right, so minus C would go down left, so something like this. So I'm expecting my answer to be something pretty much straight down. I guess we'll see what we get. All right, so we got three vectors this time. No big deal. Just take them one vector at a time. That's all we have to do. And I usually do mine in order. Some people do it differently, but I like to do mine in order. All right, so the first one there, vector A, is just going straight to the right, so there's no y component, and I know it's 2.5 long, so the x component would be 2.5, y component is 0. I go to my second vector, which is just going straight down, so since it's going straight down, it's not going sideways at all, I know my x component is going to be 0, and my y component, b is 1 for length, and since there's two of them, it'd be 2 going down, and it's going down, so I'm going to make it negative 2, because it is going down. And then I've got C, and that's negative C. Now, I broke C apart in the previous question. So if I check the components were 3.4 and 1.1, and that should be the same, except now going the opposite way. So this will be 3.4, and this should be 1.1. So it's the exact same triangle we had before, so I can just move the numbers over because I know they're going to be the same. So the x component for that one is 3.4, but since it's going to the left, it'd be negative 3.4. The y component is 1.1. That vector is moving downwards, so that'd be negative 1.1. So there's all my components. Now that I have all my components, I'm just going to add them together. So I've got the 2.5, and I've got 3.4, which is negative. I put them together, and I end up with negative 0.9. I've got these three, put them together, that's negative 3.1. All right, so I've got my total x, I've got my total for my y's. Now I'll make my new triangle. So I'm going to make a little starting nub, and I'm going to go negative 0.9, so that'll be the left 0.9, and then I'm going to go negative 3.1, so I'm going to go down 3.1. Okay. Notice I draw like tip to tail. Don't draw the negative 0.9 here and then go back to the nub and go down. You want to go tip to tail. All right. So then I go from beginning to end for my resultant. So something like this. And I can solve for that triangle. So again, I'll use my Pythagoras to solve for the hypotenuse, which is probably going to be, well, it should be low 3s. And if I check the length of that one, it's like, this is like 3.2. The angle I'm going to solve for, there's my resultant, x-axis is right there. I like to solve for my angles to the closest x-axis. So if I do my tan for that one right there, or my inverse tan actually, I can find that angle. It's a pretty big angle, it's probably like 70, 75. It's actually 74, so apparently this is 74 degrees in there, good old trig. And then I can piece the things together. So for my answer, I know my answer, it's 3.2. So it's 3.2 long at, I got that 74. I don't actually want to use the 74, because remember, you want your answers from the positive x-axis, which would be right there to the right. So I'm going to wrap it around. So it'd be 180 from there to there. 180 plus the 74 would be 254 degrees altogether. You could have gone the negative way, as well, which would be like a negative 106 degrees. It doesn't make any difference. I don't like using negative angles more than 90. I just find it harder to visualize. I don't know why. I would prefer the 254, but it doesn't really matter. Okay, and if we check our estimate from the last time we did this, here we got 3.2 at 254, and we had 3 at 260. So really, really, really close. Okay. All right, one more to go. Okay, so let's try this one. So we got d minus a plus c over 3. All right, so first of all, d was something like this. Minus a was to the right, so minus a would be to the left, something like this. And then plus c over 3 was something like this. All right, so little starting nub right there. So my answer will go something like that, give or take. All right, well, let's break apart the vectors one at a time into their components. So x, y. All right, so the first one is the d vector, which I don't think I've used yet. So I'm going to have to break that one apart. And I need to know how far sideways it goes and how far up it goes. I'm going to break that guy, the little 1.7 at 125. Now, I'll just redraw here as well. So I would use the 55 degrees. I would just find the 55 easy. You can use the 125 if you want. I would find the 55 easier to use. But people have preferences. So if I do 1.7 cos 55, and I do the 1.7 sine 55, I'll get the x and y components. So my little first vector here, my x component is, we'll round off, is like 1.0 rounded off. And my y component is 1.4. Now I'll just check my positive negatives. Is it going left or is it going right? Well, that vector is going left. So I'm going to make the x negative. Is it going up or down? Well, it's going up. So I'll leave the y component as positive 1.4. All right, that one's done. Move to the second vector. Move to the negative a vector. Okay, well, my a was 2.5 long. That's in the beginning there. It's 2.5 long, and it's going straight sideways, and it's going to the left. So the x component would be negative 2.5. It's not going up and down at all, so the y component would be 0. All right, so now I got to break apart my last one, which is my c vector. The only thing is it's a third of c, so it's not the whole 3.6 centimeters. This is now just 1.2 because it's divided by 3, but still at 18 degrees. That hasn't changed. So I will do the 1.2 cos 18. I'll do 1.2 sine 18, and I will get my components. So the x component is around 1.1, and the y component is around 0.4. You could also have just taken the components we had when we had the full-length c vector and just divide them by 3. It doesn't really matter for what we're doing. All right, so positive negative check. That last vector is going to the right, so the x component is positive. That's fine. It's on its way up. Y component is positive. That's also fine. All right, so they're all put together. So now I am going to add them all up. So I've got the -1. I'm going to add that to the -2.5, and then add the 1.1 to it. And our total x component is -2.4. 1.4 plus the 0.4, put them all together, we've got a total y component of 1.8. All right, so I've got my two totals. Now I'm going to put them together and make a new triangle. So let's see, I've got -2.4, so 2.4 to the left, and then positive 1.8, so -2.4, 1.8 up. So then my answer would look something like this, which is what it looked like over here, which is perfect. Okay, so now let's find out the answer, so to speak. So you got the 2.4, we can square that and add that to the 1.8 squared, and put them together, and then we can use Pythagoras to find out the hypotenuse, which is around 3. And then I'm going to solve for this angle right here. I like to solve for my angle from where I started from the resultant to the closest x-axis. I'm going to solve for that guy right there, which is less than 45 degrees. I can tell that already. So I get an angle inside there. It's around 37 degrees. So 37 degrees. Okay. So for my answer, the overall length is 3.0. For my angle, I'm not going to use a 37 because I want the angle from the positive x-axis. So I'd wrap this around. And of course, halfway around, of course, is 180. So if that's 37, this must be 143 degrees right there. So we're looking at 3 at 143 degrees. And if I go back and check the first time we did it, we had 3 at 140. So a really good estimate. So that is pretty much the same thing. Okay, so that's basically how it works. You know, the more you do it, the quicker you're going to get. Watch your positives and negatives. You know, look at the diagram. If it's going left, make it negative. If it's going up, make it positive. Just look at the picture. Look at the numbers. You can often tell if the x component or the y component should be bigger or smaller. And if they're not, well, you maybe just took the wrong angle or you flipped your trig function. No big deal. Just adjust it and keep on going. No big deal at all. Okay, but that is generally how it works. So it's all about taking the vectors, break them apart if you need to, total the x's, total the y's, make a new triangle with them, and that's it. And especially when we start doing this in context, it'll get even better, but we always just keep practicing. The math isn't hard. It's basic grade 9/10 math, basic trig, basic Pythagoras, that's it. But it can look a little bit intimidating when there's so much stuff going on sometimes. But once you get the hang of it, it works out pretty well.